The statement you will be using almost all the time is select. It is one of the most important statements in MySQL and SQL. Select, as its name suggests, allows you to extract a fraction of the entire data set. It allows you to retrieve data from tables. You can also hear people say this statement is used to query data from a database. Select queries can be as short as 4 words, but they may not fit in your 30-inch screen. If SQL is the principal language you are using at work, there is no chance you will spend a day without applying the select statement. The basic select statement syntax is the following. Select column 1, column 2, add as many columns as you want from the specific table, separating them by a comma. From, table name, and semicolon. Practically, the from keyword is mandatory. It tells us which table we will be retrieving data from. When extracting information, select goes with from. You are always selecting something from a certain table or other types of SQL objects. Now, when we expand the table section of the employees database, we can see there are 6 tables in this database. Lovely! Then we can expand the employees table, for instance, and see the columns section comprises 6 columns. Perfect! Assume you are interested in exploring the names of all employees. How can you do that? With the select statement. Abiding by the above-mentioned syntax, select first name, last name, from employees. This should be the query that will return an output of the entire first name and last name columns from the employees table. Let's write it down and run it to see if it works. Yes, 100%. As we scroll down in the output section, we see all the records retrieved. 2 quick notes. First, as mentioned, I will never forget to add the statement separator at the end of the query. From this point, I will not say every time that's something I am doing. Second, I might occasionally type short queries, like the one we used here, in a single line. The SQL keywords and their light blue color will help you distinguish between the elements of the statement. As we said a couple of lectures ago, I will be using the Beautify option offered in Workbench. I think it is an excellent formatting tool, especially for educational purposes, so please let me take advantage of it. It can only organize the code better. Wonderful! There is a very important thing we must mention here. Say you are interested in the information contained in the employees table. There is a substitute for enlisting all its column names between select and from. In SQL, the star symbol, technically defined as a wildcard character, means all and everything. Therefore, select star from employees should be thought of as select all columns from the employees table. Let me beautify and then run this query to verify the result is correct. Absolutely. We have the entire multi-row data from this table shown here. For each record, we can see an employee's number, birth date, first and last name, gender, and the date they started with the company. The new technique we will learn in this lesson is adding a where clause to the select statement. This will allow us to set a condition upon which we will specify what part of the data we want to retrieve from the database. This is much easier than it sounds. Let's start by checking the relevant syntax. In the body of the query, after the select from structure we've already seen, we must add the where keyword and then specify a condition. This condition can be, for example, a verification that certain information is available, a check, or a mathematical expression. In the lectures to come, we will examine all possible types of conditions to be used after the where clause. Let's look at the employees table again. You have data about thousands of employees, right? Assume you know that there are people in this huge list who are named Dennis. To extract the records from the employees table, type select star from employees where first name equals Dennis. Please note the following. First, don't forget to add single or double quotes to the string Dennis. Otherwise, your query won't work. Second, in SQL, the equality sign isn't used for mathematical expressions only. In this line of code, it means the selection of data will be based on the condition that the individual's name is Dennis. Let's run this query and see what happens. 232 rows were affected, which means we retrieved 232 instances of the employees table. These are people whose first name is Dennis. This is an operator that allows you to logically combine two statements in the condition code block. For instance, you may wish to retrieve data about all employees whose first name is Dennis and who are male. The latter would mean their gender is M. The setting of such a condition stems from the fact that not all people who carry the name Dennis are of the same gender. So, we might want to obtain a list containing men who are called Dennis only. The AND operator allows us to narrow the output we would like to extract from our data. Technically, this operator must be placed right after the first condition, first name equals Dennis. It must be succeeded by the second condition we just talked about, male. So, we must type AND gender equals M. 140 rows affected. Great! This means not all 232 people named Dennis were men, just 140 of them. Therefore, the output is a list of the records of all men named Dennis. We can execute the same query, changing the conditions in the where clause to first name Dennis or first name Elvis. Perhaps you think it is logical to obtain in two outputs, one containing a full list of individuals named Dennis and another one containing those named Elvis. However, that's not how SQL understands things. You will obtain a single output, a list of all individuals whose name is either Dennis or Elvis. This list will contain a combination of the records of the two outputs you are thinking of. Moreover, the first names will be scrambled. They are ordered differently, following the employee number. This list contains 478 rows of information, 232 of all people named Dennis, plus, obviously, the 246 people named Elvis. To prove to you that this is the way SQL understands the and or operators, let's run the same query using and instead of or. Notice how both conditions are set on the same column, first name. We execute this query and Workbench returns nothing. Ha! SQL was unable to find a person named both Dennis and Elvis at the same time. Therefore, we can conclude that we should either use AND with the conditions set on different columns, or we should use OR with conditions set on the same column. We will introduce you to the logical order with which you must comply when you use both operators in the same where block. Imagine you wanted to extract a list of all people whose last name is Dennis, regardless of their gender. We know we don't have missing data in the gender column, but let's assume you would like to specifically indicate that you wish to retrieve data about male and female individuals with this family name. Hence, after select star from employees, where you can type last name equals Dennis to show the last name of interest. Then use the keyword and. Finally, extract the information for either of the genders, gender equals M or gender equals F. Let's run the query to see if you obtain the desired output. Not at all. More than 120,000 people named Dennis? Sounds impossible. Something must be wrong with this query. The solution to this problem lies in the logical operator precedence. This is an SQL rule stating that in the execution of the query, the operator AND is applied first, while the operator OR is applied second. In other words, regardless of the order in which you use these operators, SQL will always start by reading the conditions around the AND operator. Only then will it comply with the conditions around the OR operator. Having said that, because of the way conditions and operators are structured in our code, it turns out we have extracted all male individuals with the last name Dennis and all female individuals in the data table regardless of their family name. To circumvent this issue, parentheses can help us restructure the logic of the operation. To retrieve a list of people with the last name Dennis, independent of their gender, you must place parentheses around the conditions about gender. This way, the computer will consider the first condition, the one about the last name, simultaneously with the second condition, which means the individual named Dennis could be either a male or a female. Let's execute this query to verify that what we say is true. Absolutely. Hence, remember that the logical operator precedence is an important phenomenon when enlisting conditions in the where clause. It is crucial to know how it works if you want to create scripts that work the right way. In addition, always try to double-check the results you obtain. As you saw, the first query leads us to an output 2. Nevertheless, we did not accept that output without verifying that the retrieved data corresponded to the question we were trying to answer. This was the right thing to do because, apparently, it was not the result we were looking for. So, let's see another example. Imagine you wanted to extract data for people whose name is either Kathy, Mark, or Nathan. In other words, this time we will try to retrieve a list in which not 2, but 3 conditions are satisfied. We are looking for a first name that is either Kathy, Mark, or Nathan. Considering what you've learned so far to solve this problem, you could write the typical select statement with a where clause, which includes the 3 conditions, all separated by the OR operator. Let's check the outcome of this query. 691 rows. Fine. As a second check, we can scroll over the output section to see that individuals with all 3 names appear in our list. We see Kathy, Mark, and Nathan. Fantastic! Well, there is a quicker and more professional way to approach data retrieval when we must satisfy more than 2 conditions. To do this, you'll need the IN operator. The where clause will look like this, where first name IN, open parentheses, enlist all given names of interest, Kathy, Mark, and Nathan, close parentheses. Speaking more technically, the IN operator allows SQL to return the names written in parentheses if they exist in our table. Let's verify that the query works properly. Again, 691 rows were retrieved. There is another important reason why someone would prefer the second over the first code structure. Look at the amount of time SQL needs to fetch the desired output. The IN structure was quicker than the OR structure. And please, don't think this 1/10 of a second difference is negligible. When applied to larger data sets, it will grow. Minimizing it is a primary task for SQL professional. When many conditions are to be applied in a query, the IN operator is preferred. That said, it is straightforward to imagine how the not IN operator can be used. In this case, every name other than Kathy, Mark, and Nathan will be displayed. Let's verify. Yep, it's true. The output doesn't contain any of these 3 names. Because our database contains an extensive list of records, it is normal to expect to see here only the limited by default output of 1,000 rows. Anyway, as you scroll down, you won't find any of the 3 names, which proves we've done our job correctly. Sometimes you will need to look for a specific pattern in a column. What do I mean by that? Imagine you would like to extract a list of all people whose first name begins with Mar. Such names include Mark, Martin, Margaret, and so on. To obtain the desired output, after the where clause, you must, as usual, indicate the field of interest. Then use the like operator. It is succeeded by parentheses, within which the pattern must be indicated. That's why the implemented technique is called pattern matching. you must use the percentage sign to indicate that pattern. If you search for mar percentage sign, all within quotes, because we will be looking for string values, you will obtain a list of all names starting with mar. Yes, we obtain Mark, Margareta, and so on. Good! What will happen if we move the percentage sign before R? In that case, we will get all the names ending with R. Can we use two percentage signs around the designated letters? Yes, and in this case, A and R will be found next to each other somewhere in the individual's first name. Wonderful! Okay, what's next? There is another symbol you can use for pattern matching, underscore. While the percentage sign is necessary for matching a sequence of characters, underscore helps you match a single character. If you would like to fetch all names starting with mar and written with 4 letters, you would type mar underscore within quotes and parentheses succeeding the like operator. Let's check the outcome of this query. Bingo! Only 4 symbol names appeared: Marv, Marl, Mark, and so on. Finally, besides like, one can use not like. The exact opposite operation will be carried out. As a result, when you run the same query with the condition that the first name be not like percentage sign mar percentage sign, I guarantee you won't see an individual whose given name contains the sequence mar. The between operator helps us designate the interval to which a given value belongs. That's why it is always used in combination with the and operator. If you want to obtain a list of the people who were hired between the 1st of January 1990 and the 1st of January 2000, use the same select statement structure and indicate these hire dates in the where clause using the following syntax. Where hire date between 1990 0101 and 2000 0101. Pay attention. Both values of this interval will be included in the retrieved list of records. Let's run the query. Great! As we scroll down, we see nobody who was hired before the 1st of January 1990 or after the 1st of January 2000. It shouldn't be a surprise that not between and will refer to an interval composed of 2 parts: an interval below the first value indicated and a second interval above the second value. As a result, the query for which the hire date is not between the 1st of January 1990 and the 1st of January 2000 should be read as the query in which the hire date is before the 1st of January 1990 or after the 1st of January 2000. Unlike the between and structure, here the 2 values are not included in the intervals. So, when you use not between, your list won't contain the 1st of January 1990 and the 1st of January 2000. As a final note, remember that between is not used only for date values. It could also be applied to strings and numbers. All right, excellent! So far in this section, you watched a lot of lectures and did many exercises using the select statement. Therefore, you are well acquainted with its functionality. It can retrieve rows from a designated column, given some criteria, right? And what if there are duplicate values contained in this field? Well, the select statement will extract them all. Look at this example. We will obtain the information we have in the gender column in the employees table through this query. Select gender from employees. The list is long. That's why we obtain the limit of 1,000 rows. Furthermore, the output is clear. You have many men and women on that list. Okay, great. How can you retrieve a list that contains both genders but contains no duplicate values? In such a situation, the statement to use is not simply select, it is select distinct. Hence, the syntax to abide by is select distinct columns from table name. Select distinct gender from employees will show all distinct values in one row. Therefore, with M and F as genders, we will obtain 1 row for M and 1 for F, 2 rows in total. Aggregate functions are amazing. They are applied on multiple rows of a single column of a table and return an output of a single value. This is just a definition. Things will become much clearer once we start working with 5 aggregate functions in SQL. The most notable is count. It counts the number of non-null records in a field. Sum intuitively sums all the non-null values in a column, while min and max return the minimum and the maximum value from the entire list. Finally, average, abbreviated AVG, calculates the average of all non-null values belonging to a certain column of a table. It is frequently used in combination with the reserved word distinct. Let's see how count works. The syntax to follow is select count, open parentheses, designate the column whose number of rows you would like to obtain, close parentheses, from table name. Important note: the parentheses after count must start right after the keyword, not after a white space. Otherwise, the query won't work. The logic behind this peculiarity of the syntax stems from clean coding rules. When the content in parentheses is tightly related to the function designated by the preceding reserved word, no white space must be used. How many employees are registered in our database? We know employee number is a primary key in the employees table, right? Therefore, if we count the number of records in this column, we should obtain the correct answer to our question. Type select count, open parentheses without leaving distance between them, and count. Then proceed with emp_number, close parentheses, and finally, specify you wish to retrieve this information from the employees table. Execute the query to see we have data about 300,024 people. This is proof count delivered the total number of values in the specified field, employee number. Let me refer to the lecture about the is-null operator. Do you remember when we tried to extract data from the employees table having a null name? We obtained an empty output, right? Then, we rightfully concluded there is no missing data in the first name column throughout the whole table. Now, we can use the count function to prove the same thing in another way. By substituting the column name within these parentheses with first name, we are supposed to obtain the number of values contained in the first name field. Run and... Ha! 300,024 again. The number of names and the number of employees recorded in our database match. This is how count works, and it should be more intuitive to see how count distinct can be used. It is supposed to deliver the number of different names found throughout the data table. So, if we ask ourselves, how many different names can be found in the employees table, count distinct should help us provide the correct answer. Please be careful with the syntax though. The distinct keyword is not placed after select this time. It must be written within the parentheses before the column names. So, the line of code becomes select count, open parentheses, distinct first name, close parentheses, from employees. Let's run this query to see what we will obtain. 1,275, a significantly smaller number. The interpretation is, the people in our database share 1,275 distinct names. This was a precise answer to our second question. Let's think about how you can refine your output. See what happens if you retrieve all records from the employees table. You get a list automatically being ordered based on employee numbers. Assume your boss has just asked you to order the people by first name instead of by employee number. So, how can you do that? You can use the order by clause. Adding order by first name at the end of this query will provide the desired outcome. Let's execute it to see what's going to happen. Boom! The entire list was reorganized in alphabetical order according to the field containing employee names. One of two specified reserved words can be attached at the end of the order by clause. The first one is ASC, abbreviated for ascending, requiring the output to be sorted by the values in the designated field in ascending order. If this keyword is not attached to the statement at the end, SQL will implicitly understand you want things ordered precisely in ascending order anyway. Therefore, if we add ASC at the end and rerun the query, we will obtain the same output, correct? Yes, absolutely. As you can see, the employees from the list are ordered by their first name in ascending order. The alternative is to use DESC, which is abbreviated for descending. Hence, if you would like your results plotted in reverse order, DESC is the keyword to add at the end of the order by clause. We see on top that we have names starting only with Z. Now, let's demonstrate order by does not work for columns containing string values only. This clause can handle numbers as well. Let's sort the list by employee number in descending order. Our query will look this way: descending, execute, and perfect. Here, we start from a larger employee number that decreases as we scroll down. Fantastic! Let's see another interesting feature of this clause. You can order your results by more than one field. For instance, we can order employees by first and last name. To make the comparison, let's rerun the query where we sorted our output by first name in ascending order. Good. Now, look at the order of last names. We can sort employees sharing the same first name according to their last name. To do this, we must simply type, comma, last name here. We designated the second column of interest. Execute to see if this code would affect our output in the desired way. Select column names from a given table, where some condition or conditions have been satisfied. Group by column name or column names, and then finish with order by in the same or different column names. So, for the moment, please remember the group by clause is located just above the order by clause. Let's see an example. First, what will happen if we select the first name column from the employees table? I am sure you can tell, we will obtain an unsorted list of the names registered in the database. Check what's going to happen when we group the output by first name. The result will be shorter, as only distinct values will be selected. If a value within the first name field appears in the table more than once, by using group by, it will be displayed only in a single row. Okay? Yes, absolutely. Perfect. Practically speaking, this is the same as if we used the well-known select distinct structure. The only difference is, this time, the selected rows were sorted in a different way. In addition, group by was slower than select distinct. Therefore, why would we need this group by statement at all? The answer is because knowing how to use a group by statement whenever you have aggregate functions is essential. In most cases, when you need an aggregate function, you must add a group by clause in your query too. Assume you need a list composed of two fields. The first must contain a distinct first name of the employee and the second, the number of times this name is encountered in our database. Looking for a single total value must ring a bell straight away. If we type select count first name from employees, we will get the total value of records in this table. Then, if we add group by first name, we'll split the result returned from the select statement into groups. Check? Yes, correct. That's true. In this column, we see the number of times each name is encountered. But we don't see the names these values refer to, right? Here is a rule of thumb professionals strictly comply with. Always include the field you have grouped your results by in the select statement. Let's do that. I will insert first name just before the count part. Rerun to obtain a clear output with a straightforward interpretation. Amer can be seen 228 times, Ahmad 216, and so on. Amazing! This rule is crucial because in Workbench, as you just saw, the query would run properly if you don't include the group by field in the select statement. But this will not be valid in some other databases. There, it will be impossible to execute the query if written without the group by column in the select statement. So, please stick to this simple rule. It also improves the organization and readability of your output. Make this a habit from now on, and you will avoid facing messy situations when coding. As a conclusion, I would like to remind you that an order by block can be used right after the group by block. Imagine you wanted to sort the entire outcome by first name in descending order. The code to be added is order by first name DESC. Let's run this query to see if we'll get a satisfactory output. Control and Enter, and lovely! We obtained the desired result. Having is a clause frequently implemented with group by because it refines the output from records that do not satisfy a certain condition. Probably you're asking yourself, we already learned how to use where. Why does the having clause exist? Internalizing the corresponding syntax will help us explain the difference between the two keywords. So, let's begin there. Having needs to be inserted between the group by and order by clauses. In addition, having is like where, but applied to the group by block. The difference can be better understood through an example. First, on some occasions, an identical result could be obtained by implementing the same condition, either with the where or with the having clause. For instance, should we select all employees hired after the 1st of January 2000, the retrieve table will be the same, whether we are using where or having. You see? Well, the main distinction between the two clauses is that having can be applied for subsets of aggregated groups, while in the where block, this is forbidden. In simpler words, after having, you can have a condition with an aggregate function, while where cannot use aggregate functions within its conditions. Let's look at the following example. Assume you want to extract a list with all first names that appear more than 250 times in the employees table. If you try to set this condition in the where clause, Workbench wouldn't indicate there's a mistake in your code, because this is the correct syntax. You will be shown an error message when you try to execute the query, and it will be a very eloquent one. Invalid use of group function. Change the keyword to having and add the line of code in the right place, just after the group by statement. Now, rerun the query. Ha! It works smoothly. And you retrieved 193 names that cannot be encountered more than 250 times in the employees table. Perfect! Okay, so when is the right time to use where and when should you use having? It is not so hard to decide. In the problem we just solved, extract all first names that appear more than 250 times in the employees table. You must first spot the phrase 250 times. It leads to counting the number of times something appears in the data table, and counting numbers is executed through the count function, isn't it? Is count an aggregate function? Oh yes, it is. You must use having, not where. It is as simple as that. The same logic must be applied anytime an aggregate function is required for the solution of your task. It is important to decide whether to use where or having in certain situations. It is a topic deserving more of our attention. That's why, in this lecture, we'll go through an example. Extract a list of all names that are encountered less than 200 times. Let the data refer to people hired after the 1st of January 1999 only. So, let's create the query step by step. Apparently, we must select the first names and the number of times a first name is encountered, renaming the second selection as names count. That's okay. The second thing to do is designate the table we will retrieve data from. Employees. Fantastic! Here comes the interesting bit. Should we use only where, only having, or both keywords while setting our conditions? Well, there are two conditions to satisfy to solve our problem. One is that the names must be encountered less than 200 times. 200 times immediately means we must use count, which will count the number of times a certain first name appears in the employees data table. Count is an aggregate function, and, as we said in the previous video, it must go with having. Cool. The other condition to satisfy is general. All the rows extracted must be of people who were hired after the 1st of January, 1999. This condition refers to all individual rows in the employees table. No specific aggregate function must be applied. Therefore, this condition must go with the where clause. Between the where and the having blocks, we shouldn't forget to insert the group by segment. We must group by first name, not by some other field, since our task requires us to aggregate our output by the number of times a certain first name is encountered. Good. Actually, let's order the output by the first name in ascending order. All right? Great. So, this looks like a more daunting query, doesn't it? 9 rows of code, more elements to consider while creating it. SQL starts being more fun, wouldn't you agree? Let's press Ctrl and Enter to execute the operation. 886 rows were extracted. Awesome! The query worked and solved our problem. We have a list with the number of all distinct names of people hired after the 1st of January, 1999. Let's select all rows from the salaries table. Once we do that, we'll obtain a list with 1,000 rows because, as we said, this is the default maximum of rows to be displayed in a result set in Workbench. This default limit value can be lifted. Here's how we do that. Expand the Edit tab from the main menu of the interface. Select Preferences. On the left-hand side of the window that appears, you'll have the SQL execution option in the SQL Editor section. Click on it. Then, you can untick the Limit Rows box or adjust the limit rows count as you like. Let's lift the limit completely by unticking the box. Press OK, and then rerun the same query. Wow! SQL took more time to deliver the results. Furthermore, we obtained 967,330 records. Not a lot less than a million. So many. Do you always need lists so long? Absolutely not. Here is an example of how to avoid seeing so many records in your output. Imagine your boss just told you, please show me the employee numbers of the 10 highest paid employees in the entire database. First, when you understand you are looking for top performers, as shown by a certain statistic, immediately think of sorting the output in descending order. Namely, such is the case here. We will order all individuals in our list according to their salary. For instance, to this short query, we could add the phrase, order by salary descending, and you'll obtain a list with the highest paid individuals on top. Amazing! However, this list was huge too. Adjusting the Limit Rows count from the Preferences window of the Edit tab affects any query you run from your SQL editor. Often, you might prefer setting a limit to the output of a specific query in this way. Add a limit statement at the end, just before the semicolon. It is always succeeded by an integer value indicating how many records must be displayed in our result. Your boss asked about the 10 highest paid employees, right? Therefore, limit 10 will do the trick. Correct? Correct! This was a much quicker query, and it answered our problem straight to the point. Awesome! Please note, if you order the statement by another column, the results list will be different. Let's substitute the salary column with employee number here. Execute. So, what happened? The resulting 10 records were sorted by their employee number, and they are not the highest paid individuals in the database. We can infer we must be prudent with the column we are ordering our output by, especially when adding the limit statement at the end. Great! Ergo, the syntax to comply with is putting the limit statement at the end of your query, no matter how long the query is. For instance, think of the example of one of our earlier videos, when we had to extract the number of distinct names of people hired after the 1st of January, 1999. If we must limit that output to 100 rows, we must add limit 100 at the end. And the result will be satisfactory. Wonderful! Finally, there is a third way to set a limit. Just expand this little list at the top of the SQL query editor and select a limit count according to your preference. Unlike the first two options, this one sets no default limit or a limit belonging to a specific query only. It will be applied to the queries you run at this moment, unless a limit clause designating a different limit rows count has been used. So, congratulations! This is where we end the extensive section about the select statement. It is one of the most important tools you must use when working in SQL. We hope you enjoyed watching these videos. See you in our next section. Cheers!